Hello everyone, welcome to my channel again. And today we are going to discuss the another LeetCode problem, and the problem number is 230. That is a kth smallest element in a BST or binary search tree. So let's go through the question. What we are given here is we are given a root of the binary search tree along with an integer k, and what we have to do is we have to return the kth smallest value from all of the nodes. So basically we need to traverse through all these we need to traverse through this tree and collect all the nodes, the node values, and based out of that we need to return the kth smallest value. So if you look at this one, this is, for example, this is one example one here. This is the starting node, that is a 3, and if we try to traverse this tree, so maybe we can use a whiteboard here. So let's say this is a tree, this has a 3, then I will just roughly draw here, then this is a 1, this is a 4, and this is 2. Now if you want to traverse this, so what are the elements we are going to get is 3, 1, 4 and 2. Okay, and after that what we need to do is we need to sort it basically. So once we sort this array, so once we sort these nodes, so what we will get is this list 1 2 3 4, and the kth value here is nothing but 1, and this is, as this is a 1 base index, so this is output is 1. Similarly, if you look at the problem example 2, so these are all the nodes, and the sorted list is 1 2 3 4 5 6, and return third number if you want to return, so it's going to be 3 only. So that's about the problem. Now how to solve it? So basically, like whenever we get these kind of questions, so one thing we need to understand is that like we have 3 different types of traversal. Be it a binary tree or binary search tree, we can always perform 3 different types of traversal. One is the in-order traversal, another is the post order, and third is the pre-order. Sequence doesn't matter. So like high level intuition is like let's give a try with an in-order traversal here in this case, and you will see what is going to happen. So first of all, like if you don't know what is the in-order, so let me just quickly tell here. So in the in-order traversal, first you visit the left node, then you print the middle node, and then you traverse to the right node or visit the right node. So this is a strategy for the LMR, that is about the in-order traversal. So what will happen, like once you start from the here, so first you will see, this is your starting route, so 3. Now you will go to the left of this, so you will come here at the 1. Then again if you try to go to the 1 left of 1, this is the null, so it will go back and you will print this 1 first of all, so 1 is printed. Then it will try to go to the right, that is a 2. So then again for 2 there is no left and right, so it will just come back from this place and it will print 2. Then again from this point it will come back, so similarly it will go back here once this is completely traversed. Then it will display this print this 3, and then it will again go to the right direction for this particular node. So again once it reaches to the 4, there is nothing on the left, then again it will come back, it will print the 4, and there is again nothing on the right, so it will come back, and eventually it will come back to the root node. That's it. So this is not going to happen because it is exhausted. So basically left, first traverse to the left, then print the middle node, and then traverse to the right. So if you see here, one good thing we can get is whenever we perform the in-order traversal, we always get the sorted form of list, because binary search tree, it is something like on the left hand side you will get the lower values than the middle, and on the right hand side you will always get the higher values than the middle. So whenever you perform the in-order traversal on the binary search tree, you will always get the sorted list, and once that is done, you just have to return the kth value. So in this case k is equal to 1, so I will just display, so it will just display the k is equal to for k is equal to 1, it will display 1 as an answer. So similarly you can perform the same operation on this, and you will get to know. Let's quickly look at the code. So I will just retrieve the last submission here. Now there is a follow-up question as well, which we are not considering as part of this assignment, but maybe you can I will try to make another video, or you can try to solve it by your own. Now here what I have done is I have created two variables. One is the count and another is the resource. I will come to the explanation why I have done that. And this is the function we are given, that is a kth smallest, which has two parameters. One is the tree node and another is the k. Now here I have a simple recursive function, that is Inorder, and finally I'm just displaying the result. So once you go to the Inorder, what we are doing is, if my root is null, then just return, don't traverse to the you don't need to traverse anymore. But if it is not, then first we have to go to the root of left. Once that is done, you need to increase the count operation, because after that you have to print, you have to store the result value in the result variable. And let's keep this part for now, and then you will traverse to the right. Okay, so this way you have to visit to the left, then print the or store the middle value, and then traverse to the right. So what will happen, once the count reaches to the k, that is going to be our answer. So in this case what we have to do is, so first of all, here in this case it will come to the left side, so the count will be increased by 1, then here count will be increased by 2, and then once you go back here the count will be 3, and then for the last unit count will be 4. But we don't need to traverse in this case, because as soon as we get the first element, so we don't need to traverse the tree anymore. That's it. In the worst case you have to traverse the whole tree, but if the kth value is lesser than that, that would be our endpoint. And once the count value reaches to the k, we just have to store that result root dot value into the result, and finally we have to display the same thing. So this solution is available on the GitHub. I will update the GitHub link, solution GitHub link in the description of this video. Thanks for watching. Bye.